When we compare the columns of holding cost and storage cost and shortage cost, we noticed a relation between these two. When one is zero, the other one is positive, and when the other one is zero, the other one is positive. So if I refresh it many times, you will see this rule works for all of them. In fact, in each line, one of them is zero. Let's check it, for example, here. Holding cost is zero, holding cost is zero. Here, the shortage, shortage, shortage. You cannot find anything here that both of them are positive numbers. One of them is positive and the other one is zero. And it makes sense because two things can happen. Demand is greater than Q or demand is smaller than Q. If demand is greater than Q, so you would have shortage cost and the other one is zero, and in other situation that demand is smaller than Q, you will have storage cost and shortage cost is zero. So this is another way that you can check if you have done everything right. And finally, we come up with the net profit. Net profit would be gross profit minus holding cost minus shortage cost. And that's it. Now we are going to populate it to get 1000 simulation for 1000 months for net profit. And again, the formula that we used here, you can find it in this formula bar. That is gross profit minus holding cost minus shortage cost. Now we have net profit column calculated. Now we can go for the service level. As you remember, and also now you can check with your PowerPoint that about the service level description, that is the percentage of the total demand that is satisfied. So here the formula would be this, the percentage of the total demand that is satisfied. Okay, what is the demand that is satisfied here? It is Q. Why? Because demand is greater. So if we want to put that on the situation, okay, for example, for here, it is 100 over 155. That would be service level. The demand is 155, but the Q is 100. Here, the demand is 83 and Q is 100. The service level is 100. So the formula that we need to put here is this. What is the service level? Service level would be the satisfied demand over the total demand. So in this formula that you see here, the total demand is D3, 155. Okay, but the satisfied demand is the minimum amount between Q and demand. If Q is greater than demand, the satisfied demand is demand, but if demand is greater than Q, the satisfied demand is Q. Makes sense. For example, when you have here 155 demand, the satisfied demand would be 100 because we only have 100 inventory, and but here demand is 83 and we have 100 as inventory, but the satisfied demand would be 83. So the formula would be this: minimum of C3 and D3 over the total demand. So I'm gonna calculate this, and since we want everything in percentage, we are gonna change the format. As you can see, where is it? Okay, number here we have percentage, and let's go without any decimal. So we have this, and if I populate this, we come up with this. Some of the periods have service level of 100. That's correct. I mean, the number is fixed. Which periods have the fixed level and the full level of service? That is 100%. The levels that your Q is greater than D. So let's check it here. Q is 100 and demand is 79. So the service level would be 100. Here, we have again Q100. So anytime that demand is smaller than Q, so that's the one with service level of 100%. Just, my friend, let me give you a point. It is not the only way to calculate the service level. Again, I choose the simplest one because I want to have our focus on the simulation model instead of those details. Here, I did it very simply. I calculate the service level in each month, and I'm going to calculate the average. But you can do it in another way, that you calculate the total demand in 1000 months, and again calculate the total satisfied demand, and that total satisfied demand during 1000 months over the total demand. Again, you calculate the average service level. But I use this because it is easier to grasp, but feel free to ask if you have any question about the other ideas that you have, because it is simulation and it is very flexible technique. Depends on the way you like to do your model, but the answers should support each other. Okay, here we have average net profit, that we get the answers here, and we have average service level here, and after that our simulation is done with Q100. We have the result of our simulation. It says that if you use the average inventory level of 100, your average net profit would be 4,261. And if I refresh my simulation, you see the answers are totally around similar numbers, and all of them are in the channel of 4,200. And it's very reliable results. And when you see about the service level, it seems they are always in the channel of 93%. So now we can announce we are done with activity 1 and simulation at this phase. Okay, this is activity. It was activity 1. Run a 1000 month simulation model if Q equal to 100. And for the other one, in activity 2, to finish the case completely, it says compare the net profit and service level for the 3 different levels of Q as 75, 100, and 125. And which one we are going to use? The one that has the maximum net profit and maximum service level. So again, we need to return to our Excel file and do these calculations. This is the structure I'm considering for answering activity 2. You can use any structure you like. And okay, so you see here we have 3 different Qs: 75, 100, 125, and for each of them we are going to calculate the average net profit and average service level and see which one is the best. Okay, we already have the answer for when Q is 100, so I'm going to put 4231. I'm just rounding up the number, not important. And the next one is 93%. 93%, I put it here. The next one we are going to do for 75 and check the answer when Q is 75. Let's see what would be the average net profit. We have everything is average. So you see, obviously, both the average net profit and average service level is lower than the other one. So far, the Q100 would be the better option. And when we go for 125, and just to show you, see, I just changed that 75 here for all of the items that we have. And just to show you, because of the formula that we had here, it would create no problem because we put all the formula based on the demand and Q, not about the numbers. It is about the cells. So it is being updated immediately and it would be fine. And here for 125, if I put 125 here and I populate this number to the other cells, and we got the answer, and the answer is 4503.4. I'm rounding them up, and the other one is the awesome service level of 99. So obviously this the winner is Q125. If you want to continue and to find the best Q, since after adding 25 to 75 we get to 100 and we get better profit and better service level. After adding another 25, again we get better, and again we got better profit and service level. So it makes sense we continue adding, and in that situation you will find the best answer. But I guess now you got the point, and it is the winner. Let's color it as this, and that's it. It is now the answer for activity 2, and Q as 125 is the best one. And sometimes students make some mistakes. So let me tell you about that mistake in the remaining time. See, when they write the formula, for example, about the gross profit, instead of saying putting sales like C3 and D3, they put numbers. For example, they put if demand is greater than 100. Okay, so they put it the C3 greater than 100 and do everything according to that. But when they come and change the numbers, for example, here, instead of 100, they run their model with 125 according to activity 2. But since only this part has changed, the answers regarding gross profit, holding costs, and all those things would be wrong. So I strongly recommend that when you are doing simulation models, don't use rigid numbers, don't use fixed numbers regarding the formula that you put, because as you can see, when you changed it, you need to change all those formulas again. So here we have 125, that's fine. For demand, it is always has the mean of 120. Regarding activity 2, it doesn't ask us to change the demand. It talks about changing the Q. So that's the reason I didn't touch this part. For the gross profit, it is completely depending on the demand and Q, so we can easily generalize the formulation we had to other numbers of Q.